And thank you very much for accepting our request. Okay, I know you are so busy with a lot of schedules and all, but very much thanks for accepting our request. And a lot of curious students are waiting over here. So if you can see the window, multiple classrooms are already connected. So people from diamonds, gemology, even CAD, jewelry design manual, and even from manufacturing department, they have joined. So you can start with the basic intro about yourself, and you can. So we all will be waiting for you. And at the end of the session, it will be appreciated if you have some time for Q&A session. Okay. So now the stage is yours. You can take it.
Thank you so much, Jerry. Initially, when Jerry had approached me for this particular lecture, I was pleasantly panicking inside. I did not show that to Jerry because it has already been a decade since I've spoken to people like this, right? So I remembered a quote from Eric Thomas, which said, whenever you face challenges in life, just remember pressure only makes diamonds, right? So pressure is a part of success. So based on that, I'm going to be starting this particular lecture with you guys because all of you over here love diamonds and think diamonds are precious and you're all investing your time and money towards it. Similarly, even myself, I have been investing my time and a lot of resources in understanding what diamonds are, even for jewelry, even for the other applications that we would be talking about. So my name is Harish, and I had completed my BTechs from NIT Trichy in 2017. Right from then, I had been, spending my time doing business development, marketing in multiple companies and multiple roles. 4 years back, I had joined a lab-grown diamond company in Surat. And since then, I've never turned back, never looked back. Diamonds have been my one love. And today I would love to share a little bit about my love towards diamonds, especially the scientific applications with you all. So I hope you all enjoy this particular lecture because I'm going to be talking about something very interesting, something that you've not been exposed to as of now. So let's begin. Let me know if my screen is visible.
Yes, we can see it.
Yeah. Can you see the presentation?
Yes.
Perfect. All right. So we're going to be discussing a lot of things in this particular presentation, right? Initially, our motive is to understand how lab-grown diamonds are going to be used for future technologies. That's going to be our main motive. But let's just see. So today's agenda will be learning how lab-grown diamonds are in jewelry. And one more thing, you don't have to take notes or you don't have to take screenshots. I'd be sharing this particular presentation with Jerry and across to you. So I hope you just listen to me because those are the things that you would love to, keep stored in your brain. So why lab-grown diamonds are special, right? And specifically, what does doped lab-grown diamonds mean? And there are other potential applications of lab-grown diamonds. What are those kind of applications? Then we're going to be throwing some spotlight on some key applications that are being used in today's technology. And we're also going to be learning how these lab-grown diamonds are created today and the different CVD methods that are used. And finally, we're going to be talking about some of the challenges that we will be facing with these kind of diamonds and what is the future outlook for these kind of diamonds, right? So lab-grown diamonds in jewelry basically is very simple, right? I mean, you guys know this better than myself. So I just put this screen to, have an icebreaker with you all guys, maybe even put a small smile on you. So lab-grown diamonds in jewelry is something that you all know. So I'm going to be skipping it completely, right? Something that lab-grown diamonds have already done. Many people have been exposed to this. So the main usage of diamonds in jewelry is what everybody know today. So I'm going to be completely skipping this. All right. So lab grown diamonds actually are very special, right? But to be very honest, it's just a rock, right? I mean, even this rock, you don't even, when it's actually just a rough, you don't even feel like there is something special about this particular rock. It becomes special only when you start cutting it, polishing it, and then, you know, do a lot of processes, and then you bring out the inner beauty of the diamond outside. So here in lab grown diamonds, about the technical features, right, there are some unique properties that actually make them very, very special. The image given on the side is the lab that is a CVD reactor lab. This is where all these lab grown diamonds are created, right? So we're going to be discussing some key unique features. The first thing being its hardness, obviously. This is what we all tell in our jewelry, right? I mean, it's not going to break, it's not going to get scratched, it's going to stay forever. All those forever terms come because of this particular property called hardness. And on the Mohs scale, to give you some technical detail, on the Mohs scale, it has a rating of around 10, right? Which is probably the highest for any known natural material, right? So if there is anything that is natural and has 10 on the Mohs scale, only diamond is the material. So this particular property, like I said, it's going to help you from, you know, preventing anything from getting scratched. And like I already told you, only a diamond can scratch another diamond, only a diamond can cut another diamond. So similarly, these diamonds are going to be used as wear resistant coatings and cutting tools. So one of the most important properties. Next is thermal conductivity. So to give you a small idea of what thermal conductivity is, a simpler word will be heat spreading. So we all know what spreading means, right? Spreading means from one point, it starts moving. So the same term, if we bring it to thermal, that is thermal is heat, obviously, right? So when you put heat in one point of the diamond, it doesn't stay in that one point. It starts spreading over the diamond. And in diamond, it is the most amazing material because it has the highest thermal conductivity. What that means is there is no other material which can spread heat like diamond. So it has around 2000 to 2200 watts per meter Kelvin, which is the highest for any known material. To give you a small idea, we all know what copper is, correct? So since this is a virtual meeting, right, guys, I don't think you'll all be able to say yes or no, but I'm going to keep the video on. So if possible, you can nod so that I can know that you're actually listening and, you know, getting the points that I'm talking about. So extremely in copper, the copper material has thermal conductivity of around 350 to 400 watts per meter Kelvin, right? So to give you an idea, diamond has around 5 times thermal conductivity of copper. So if copper is able to dissipate heat within 1 second or 5 seconds, diamond will be able to do same thing within 1 second. So that is what it means, right? So this is one of the most important properties because in most of the applications where diamond is used in applications where there is extreme heat, extreme pressure, and a lot of corrosiveness, acids, bases, all these harsh conditions only diamonds are used. So this is one of the main properties that make it crucible in high temperature or low temperature regions, right? The next is diamond has a very high electrical insulation. So a pure diamond is actually an insulator. I think you all guys know what an insulator is and a conductor is, right? Great. So diamond is actually a pure insulator. So if you take a diamond, which is purely only carbon to carbon bonds, right? So you all know that diamond is made from coal. If the coal is subjected to a lot of temperature and pressure, it turns into diamond, right? So this particular structure has only carbon atoms in it. Okay. So when it is only carbon atoms, this particular material is a pure insulator. That is, no electricity can pass through. If you hold a diamond and you place it on some wire which has a lot of electricity, you won't get affected because of it. Because diamond is such a great insulator. And if you look at, there is another word called wide band gap. So band gap means basically it's the difference between the energy levels to make certain materials a conductor, right? So if the band gap is very low, or if it is in the minus, or if it is in the minus, that means basically the particular material is a conductor. Here, diamond has a band gap of around 5.5 electron volts, which means it is an excellent insulator, right? So this particular quality makes diamond usable in power electronics and high voltage applications. Have you seen these power grids? So there are these power grids, right? I mean, where there is a lot of transformers, a lot of things happening, a lot of electricity passing through. All of these places can use diamond as a safety mechanism. So there is always a safety mechanism. Even in our houses, you must be knowing something called a fuse, correct? So I think you would have seen this particular fuse concept in a lot of movies. So some hero would take the fuse out, or some villain would take the fuse out to completely shatter the electricity. Why this fuse is there is because if the temperature or the electricity is too higher, or if it's going beyond a limit, then this particular fuse will melt and the entire electricity will be shut down. What this prevents is it prevents a lot of fires, a lot of hazards, right? So same kind of fuse mechanism, if you need it near a volcano, near a nuclear reactor, near, let's say, a space application, all these places, the pressure is high, the temperature is high. Near a volcano, there is a lot of poisonous gases, a lot of acids in the atmosphere. So these kind of places, you need materials that will not get affected by these conditions. So that's where diamond can be used, right? So it is very much helpful in all of these power electronics and high voltage applications. Then we all know what this is: optical transparency and high refractive index. Okay. So diamond is actually used in jewelry mainly because of its optical properties. I mean, wouldn't we all agree? It's sparkling, it's shining, and that's probably why we all, cut these diamonds into different shapes. We use it in all kinds of jewelry. Same way, these kinds of optical transparency property is used in other applications as well, right? All of us, most of us would be wearing a specs. Even I can see somewhere some people wearing specs in your class as well, right? So this particular specs is made of some other material which is optically transparent. Let's assume that you are working in a mine, or let's assume you're working near a volcano. Let's assume that you're working near a nuclear power plant, a reactor, or something like that, where there is a lot of radiation and you need to protect your eyes. That is where you will wear diamond lenses or diamond mirrors. So diamonds have a high optical transparency. So in the optical spectrum, right, light actually has a spectrum. There are different kinds of lights. There is UV light, ultraviolet light, which you get from the sun. There is something called visible light, the different colors that we see from our eyes. And there is something called infrared light, right? So all of these kind of lights can pass through diamond and come out that side. So this is one of the most special qualities of diamond, because using this particular application, there is a lot of products that is being created today. Okay. So refractive index. I'm not sure how many of you know the meaning of refractive index, but refractive index is simply the ability to bend light. just understand that, any light that is passing in the vacuum, we all know that light has the highest speed, right? We would have heard in that school, 11th standard, 12th standard, even 10th standard, they would have told us about it. 10 to the power of -8, 3.0 into 10 to the power of -8 is the speed of light and all that, right? So that light, if it passes through some material, the speed of the light reduces. And because of this reduction, the light slightly bends, and that is called diffraction. And this property is what is used in your jewelry to make the diamond sparkle. Okay, so the light that enters into the diamond is actually not able to escape outside and undergoes something called total internal reflection. I'm sure you've heard this term in your classes. So this TIR is what makes the diamond sparkle. What makes the light, come out of the diamond in a very, very beautiful manner. So this is happening mainly because of a high refractive index that is in diamond. Okay. So the last one, of course, very important one. To be very honest, it's the most important one of all. Chemical inertness is what makes diamond, I've been talking about volcano or nuclear reactors and completely harsh conditions. This particular property is what makes diamond is completely usable in all those conditions. It's chemically inert. Inert meaning it is not going to react with any of these foreign substances, any harsh substances like acids, bases, whatever, right? And finally, it's biocompatibility. So diamond is actually not just a best friend for a female, for the women that we have as partners, but also living things, us, all of us, we need diamonds in a very, very, medical sense, because diamond is a material that you cannot react with any of the things that is happening inside the body. We know, or we have some relatives, we have some friends who have titanium rods as bones, correct? There will be, if they have some fractures or something, they would plaster it with some POP, and inside there are titanium bones, titanium nuts, all of these things. Now, this titanium can be coated with diamond. So what this makes the titanium is, it makes them more biocompatible. So your blood, the minerals inside our body is not going to affect the particular material, and that material can stay forever. Very interesting fact is, if you have a diamond plated rod fitted inside your body, and they cremate you, or cremate you, basically that diamond stays alive forever. So this is a very interesting fact about diamond as well. So I want to show you a little bit about why diamond is mostly very, very special, right? I have listed a few materials here, along with lab grown diamonds. So there is silicon. So silicon is a material that you can find everywhere. You take your phone, you open the phone, you can see a lot of circuitries that is made of silicon. All the brown color boards that you see is made of silicon. So silicon is the mostly widely used material in today's life because of electronics. Everywhere and anywhere you use silicon because it's very cheap. So silicon basically comes from sand, and sand is available everywhere. Wherever there is land, there is sand, right? So silicon is the most abundantly used material today. So we have that as comparison. Then there is silicon carbide, which is SiC, which is a slightly better version of silicon. In fact, a much better version of silicon. There is a lot of research going on today based on this particular silicon carbide. And we have copper. Copper is something that we all use for wiring because of its electrical conductivity. It is one of the cheapest conductors that is available today. And we have sapphire. Again, sapphire is something that you must be knowing because it is part of the jewelry line. Now, sapphire is very interesting because of its optical abilities again. It is transparent mostly, and it is beautiful. And there is alumina. Alumina is again a material that is used in many places. And there is titanium again, which I spoke about. So if you can see the data that is given, right, I have listed the hardness, thermal conductivity, optical transparency, refractive index, whatever we had just discussed. In all of these things, you can see that lab grown diamond specifically is having the highest of ratings in all of these things, right? I mean, if there is a material that is as special, that is amazing across majorly three things, that is temperature, one is optical, and electronic abilities, it is only lab grown diamonds. It is just diamonds that is amazing across all of those things, right? So this is something that I just wanted to show you so that you will get an idea based on what I'm just talking about. So be it anything, like I told you about hardness, thermal conductivity, optical transparency, refractive index, electrical resistivity. Resistivity just means how much opposition is there towards electricity, right? So that is the term that they use. It's called resistivity. So then there is breakdown voltage. Okay, so breakdown voltage means very simply, in simple words, it is just how much voltage you need to break the insulator and make it into a conductor. Okay. Um, I mean, it's just how much ever voltage that is required, that is needed for this particular process. And of course, we've spoken about chemical inertness and biocompatibility. So I think you would have an idea about how lab-grown diamonds can become a scientific, marvel in technology, because there is no other material that is like diamond. It's not just optically transparent. It is hard and it cannot be scratched. It is not just hard, but it can sustain high temperatures. It cannot just sustain high temperatures, but it can also sustain a lot of chemicals, a lot of harsh chemicals. It cannot just do that, but it can be part of our body inside. It can help us live longer. All of these things are present only in diamonds, right? So that is why we are having this discussion together today. The next thing is something that we would like to discuss is doped lab grown diamonds, right? So the meaning of doped is basically adding some kind of adulteration. I think you would have heard this term called adulteration, right? Adulteration in food, adulteration everywhere. All of those things basically means, adding some kind of, material, foreign material that is not originally present in that material. So doping means adding something that is not part of our body. Same way in lab grown diamonds, doping means adding something other than carbon. It simply means that carbon is the only element that is available in a pure diamond, right? So some ways a pure diamond is not going to be helpful to us, especially electronics. We just spoke about how diamond is a pure insulator and you need a lot of voltage to make it a conductor, right? Similarly, if we want to use the same diamond as a conductor, we need to introduce certain foreign elements inside this particular carbon structure. And that is called doping, right? So we are going to be talking about different kind of elements that are being doped inside this particular structure, carbon structure. The first and foremost element that I would like to discuss is boron. Okay. So in our laboratories, when we create lab grown diamonds, so we mix boron into the mixture of gases to make the lab grown diamonds a little more shinier, a little more bluish white, right? To improve the color of the diamonds, we include boron gas. The same boron gas, when we include into the structure, this particular boron makes your diamond a semiconductor. So semiconductor, basically what it means is, we spoke about insulators and conductors, correct? So this particular semiconductors comes in between these two things, that is insulator and conductor. So the beauty of a semiconductor is basically it is not a complete insulator. At the same time, it is not a complete conductor. So you need to introduce a small voltage to make the insulator into a semiconductor. So how many of you over here has done science in your 11th and 12th? Can you please raise your hands? Just one of you? Okay. So after this particular session, you've got to trouble that guy over there and find out what semiconductors are used mainly and what I'm going to talk about, diodes, right? So in our phones and electronic components, right? You can, if at all you've broken a remote controlled car or a remote, basically a TV remote, you've seen your parents throw the remotes, or you yourself, when you were angry, you throw the remotes, right? And it breaks. You can see the circuit board in between, correct? And on the circuit board, you can see a lot of small cylinders. Those cylindrical parts are called diodes. Okay. So this particular diode has semiconductor in them. The main purpose of this diode is basically, if the voltage is not high, when you press the TV remote, right? When you press the TV remote, only the remote works. Have you noticed that? You have the battery already into it. Even in the remote control car, only when you press something or when you turn something, it starts working, correct? So why this is happening is because initially, even when the battery is there and there is a lot of charge going into the circuitry, the particular thing does not work because there is diode in it. So diode, what it does is, if there is minimal current, it won't let it pass through. When you press the button, there is more voltage going the diode. So when there is more voltage, the diode starts working. The diode becomes a conductor. This is the main application of a diode. Okay. And a diode is basically made of a semiconductor. So the application of a semiconductor is to facilitate conduction only when we want it. If semiconductor was not available in our world, then what will happen is we would be electrocuted. Every time we will have shocks anywhere and everywhere. Whenever there is electricity involved, we would be shocked again. And I don't think none of us want to get shocked when we are using some remote or when we are using something like that, right? So the main purpose of a semiconductor is that. And there are two types of semiconductors. One is a P-type semiconductor. P-type, just assume it means positive type. Okay. And there is another type of conductor called negative N-type conductor. N-type conductor. So whenever we say positive, so when do we say some people are positive? When they give us something, correct? I mean, when someone is giving something from their pocket or something from their lunchbox or something from their own, we call them a positive people, we call them good people and all that, right? Exactly that same concept is what we are going to do here as well. So whenever a semiconductor is able to give, it is called a P-type semiconductor. Okay, I'm not going to get into a lot of science here. I don't want to bore you people. I know it's early morning. It's very easy to fall asleep when we are talking science, especially in a class where only one science student is there. So very simply put, it's a material that is able to give a lot of things. Okay, that is what a P-type semiconductor is. So we're going to be using this particular material, where a material with boron in it, diamond, It's used in a lot of devices like transistors, diodes, and many more. There are thyristors. There are many devices like that. So these kind of electrical components use semiconductors. Okay, so the same material is highly resistant to radiation damage. Again, when we have a nuclear reactor, if you have a boron doped diamond and it is coated on your particular coat, the lab coat that they wear, basically it will protect your entire body from all those radiations. Okay, that is the main application. Then let's talk about nitrogen. So nitrogen is again one of the most important gases in the production of lab grown diamonds. If any of you in the future is getting into lab grown diamond business, this particular gas is going to be in your continuous supply of gases, because in our growth process, nitrogen is used to speed up the growth of the diamond. Okay, so whenever we are creating lab grown diamonds, we slowly deposit carbon atoms on a diamond seed. Okay, so this particular process can be amplified. The speed of the process can be amplified using nitrogen gas. That is the main application of nitrogen gas in a growth process. But when we are using this nitrogen gas in the growth process, what happens is this nitrogen will get into the diamond structure and form a nitrogen vacancy, this NV center. The simple name for that is NV center. Okay, so this NV center is very special. Pardon me for using very together, but it's actually damn special. So we're going to be talking more about that NV center in the next few slides. But what is the main usage of this NV center is, I think most of you would have heard this term called quantum, correct? Can you please give me some kind of a shake or raise your hands if you've heard this term called quantum? Yeah, perfect. So I think most of you guys who have heard the word quantum, I think you would have all been computer nerds, right? I mean, there is this quantum technology. There is a lot of hype over there. So quantum technology is basically, so the phones that you use right now, the iPad that you use right now, the laptops that you use right now, use a concept called classical computing. Okay, so classical computing basically uses binary language. I think you would have heard about the 0 and 1, right? So 0 and 1s are the only language used in today's computers, in your technology, all of those things. But there is something called quantum computing. Okay, so quantum computing uses three things, not just 0 and 1. It uses 0, +1, and -1. So just understand these many things, right? It uses something extra than the classical computing. In quantum computing, everything that is going to happen at a very fast rate. It is going to be extremely fast, and it's going to be able to do some of the calculations that we were not able to do in today's computers. Okay, that is the main attraction of the quantum computers, right? So this particular nitrogen is going to help a diamond become a material that is going to be used in the quantum computing. Okay, so there is something called quantum sensing communication. So quantum is actually a very fancy word right now. There is computing, there is sensing, there is communication. All of these things can use quantum. So let's not get into detail. No, none of us are going to become the next Einstein. Me included. So we can move to the next topic, which is phosphorus. Phosphorus is again a very interesting material. Just like how boron is going to create a positive type semiconductor, phosphorus is the bad guy. He is going to create a negative type semiconductor. Okay, just understand a negative person. What is a negative person? Negative person is someone that takes our things without our permission, right? So negative person is someone that says wrong things that we don't really need in our life. Same way, a negative type semiconductor basically takes out all the energy from the rest of the things. So in our world, how we need positive people and negative people together, right? Only then the world can move forward. If you only have positive people, I think the whole world will be giving, 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 giving. It will not work out. Same way, if there is only negative people, they'll be taking, taking, taking. The world will not exist anymore. So if you have positive and negative together, there is give and take. So this is what makes us move forward as a race. Humanity is moving forward because we are giving and taking at the same time. Similarly, in electrical components, you need both positive and a negative type semiconductor to make a perfect electronic component. Remember that I spoke about diode, the cylinders inside the circuits, the small cylinders. These particular cylinders will have both these type of semiconductors. It will have the positive type of semiconductor also. It will have the negative type of semiconductor inside that small cylinder. That's how it works. Okay. So phosphorus basically makes a positive type semiconductor. It is again going to be promising material for high power electronic devices. And all these EV vehicles, the new fashion trend, right, in bikes and cars is the EV vehicles. So EV vehicles are going to be in the future. Right now, it is not fully diamond yet, but there is a lot of research going on to make the batteries, to make the circuits using diamond, using this positive type semiconductor, using these negative type semiconductors, right? So in the future, all of your vehicles, EV vehicles will have batteries, circuit boards, all of this made of diamonds. Okay. Next is, again, this is also very interesting, oxygen. So I'm not going to be dealing a lot with these three things because these three things are not going to be primarily used in a lot of applications anyway. But oxygen, basically, if you introduce oxygen into the growth process, basically it is again going to create a small point defect. I think most of you know what a point defect is, right? Do you know what a point defect is? I think when you grade a diamond, you called a point defect, right? So point defect is what on the diamond surface, if there is a small defect, that is a point defect. I'm not sure if I'm correct in gemology. Jerry might be able to help you out with that. But same way, in the diamond structure, that is the carbon structure, on the top layer, if there is a defect introduced, it is called a point defect. So oxygen basically acts like a point defect. It will not go into the carbon structure like nitrogen. Like, see, nitrogen, boron, and phosphorus will go into the carbon structure. But oxygen, basically oxygen, hydrogen, both of these things will be staying on the surface layer itself. So what oxygen does is, if there are any other defects, any other materials, any other elements that is gone into the diamond, it will remove that particular defect. Okay. So it will basically improve the structure. Lattice means just like how we have bone structure. If you remove the muscles, you can see bones inside our body, right? Same way, if you remove the outer things in a diamond, you can see the carbon structure. It's called lattice. Lattice is the bone structure of diamond. Any element or any compound. Okay. So what this oxygen doped diamond does is increases the wettability. So it makes them hydrophilic. Okay. So hydrophilic, hydrophobic. There are two terms. Do you all know that? Can you give me a nod? Okay. Hydrophobic. Phobic. What is phobia? Phobia means we are scared of something. We have an aversion towards something, right? So same way, phobia means it is something that we are attracted. So hydro means water and philic means attraction. So basically, whenever we put oxygen into a diamond, that particular diamond will attract water. Okay, this is all that means. So what this particular property does is it can be used in a lot of water purification systems. Okay, In today's world, we have something called RO, correct? RO systems, RO purifiers, all these purifying systems are there, right? So in the future, we will have diamond purifiers. So for that particular reason, oxygen is going to be very, very helpful as a dopant. Okay. We have something called hydrogen dopant as well. So hydrogen, again, it's similar to oxygen. It's going to passivate the grain boundary. So grain boundary means the same thing, the top layer of the diamond. So the top layer, the grains will be there. All these carbons will be in a hexagon shape, right? So all these carbon layers will be, if there is any other defect, basically hydrogen will remove them. And what this will do to the diamond is it will improve the electrical performance. So any kind of boron doped diamond can be, doped with hydrogen also, so that the top layer, the boron will be removed. But whatever boron is inside the bulk layer will be still present. That is the main application of hydrogen here. Okay. And it is also going to enhance the thermal conductivity of the diamond. All right. So in fact, if you would have noticed in the starting, I would have shown you a range of thermal conductivity for lab grown diamond. 2000 to 200 I showed you, correct? So why I showed you 2000 to 200 is because a normal diamond, a natural diamond that you can see in your everyday classes, a natural diamond will have a lower thermal conductivity than lab grown diamond. Because in lab grown diamond, we are basically mixing all these foreign elements. Understood? So if you would have come across a lot of advertisements from all these lab grown diamond companies, they say lab grown diamonds are better than natural diamonds, better than natural diamonds. This is why they say that. Basically, a natural diamond cannot be made into all these things, but a lab grown diamond, you can introduce all these factors when you're growing it. Right? You cannot go millions of years back and introduce all those things, correct? So that is one advantage when we talk about lab grown diamonds, specifically when we come to technological applications. Okay. And the last one, I'm pretty sure even the science guy wouldn't remember this particular element. It's called erbium. Okay. It will be in between the periodic table that you would have seen in the chemistry book. I'm not sure what your name is, but let's call you the science guy for now, right? So this particular element called erbium is somewhere in between the periodic table. Okay. It is basically a rare earth element. It's not available a lot in our earth specifically. So this particular erbium is actually used to increase the energy levels for optical transitions. Okay. So optical transitions occur in nitrogen also. So this NV center, right, we talked about, the nitrogen vacancy center is basically, it's an optical transition. The NV center basically gives out some light. Whenever you see that particular NV center in an optical microscope, 100x, 200x microscope, when you see it, it will have a different color apart from the whole diamond. Right? So this particular erbium, when you mix it, it will make this color of the light more darker. It will make this particular diamond more efficient, right? And this will make the particular diamond emit specific wavelengths. So wavelength, whenever we speak about wavelength, it is just about the color, right? So I'm not going to confuse you with a lot of technical knowledge there, right? Again, so this particular erbium can be doped into the diamond to make lasers. Have you noticed that lasers have a red color light? The small kid laser that we play with, we've done a lot of naughty things without laser, right? So that particular laser has a red color light. Similarly, there are other color lights also, yellow, blue. All these lasers and optical amplifiers, they can use diamond as a material. Okay, so this is where it's going to get very interesting now. Okay, so I'm going to be giving you 10 seconds time. If you want to shake your body, just, there's a lot of knowledge that we have given. So take a small 10-second break, do whatever you want. Have some water if you want, because this is going to get a little more technical. We're going to be talking about some products that are being used in day-to-day life that is using diamonds. Okay. Okay, your 10 seconds starts now. Okay. Right. So I think 10 seconds is over by now. I'm not sure, but I'm going to be starting, right? So potential applications, we're going to talk about some of the applications. These are the main things that you should be knowing because all the things that we've discussed before this is all technical, but these are products that we will be using in day-to-day life. In our future, our kids will be using these products, which are made of diamonds, right? So the first thing that we are going to be discussing about is quantum technologies. Uh, Quantum technology is going to affect our life in a major way. The last time our life was affected like this was when steam engine was created. Okay. Steam engine basically made the entire world move at a very, very fast rate. Before steam engine, there was just bullock carts, people carrying the vehicles, pushing the vehicles, all these things were there. But when steam engine came into place, this happened 200 years back. Not sure, 200, 150 years back. So when steam engine came into place, what happened was their transportation became a huge success. India lost all of its resources because of the steam engine railway that British had introduced in our country. Okay, all of our resources they had transported from one point to another because of the steam engine. So steam engine changed the entire humanity, to be very, very honest with you. If steam engine was not there today, we would not be moving from one city. That is, you're all in Bangalore right now, and other people are in some other cities. But you can reach Surat, where I am right now, in the next 4 hours, 5 hours through flights. Okay. And flight is just the better version of a steam engine, seriously. Right. So steam engine made that possible. Initially, the traveling they took days, months, but steam engine became so popular that, traveling became so easy. Same way, quantum technology is going to change all of our lives, all of our kids' lives, because the computers that we use today are comparatively slower. If you can believe this, I don't know if you can believe this, but it's actually slow. Quantum computers can do what a classical computer is doing in, let's say, 10 minutes. The same thing can be done by a quantum computer within 10 seconds. If you can really imagine how big a scale that is, it's huge scale. 10 minutes to 10 seconds is a very big improvement. So what this is going to do is it's going to make our lives difficult in a way, because already computers, all this extra knowledge is we are forced to learn all these things, but quantum computer is going to make that 1,000 times more faster, right? So in quantum technologies, we have computers, we are going to have sensors, we are going to have storage devices. So all these three things are going to be made using diamond in the future. Okay. Then we have something called electronics and semiconductors. So semiconductors, I'm not going to go in more because we have discussed a lot about it. So electronics on a whole is basically a combination of semiconductors, conductors, insulators, all of these things, right? And diamond can act as an insulator, like we discussed. It can act as a semiconductor. There is a lot of work going on to make it also a conductor, but it's a future thing. So today, diamond can act as an insulator and a semiconductor. So basically, there is going to be a lot of products made in this particular segment. So there is something called heat sink. So heat sink, you know what sink is, right? We all have sinks in our homes, in your classes. So sink is basically it's a play, it's a device that will throw all the water into the center of the sink. Basically, it's a bowl, and whatever you put in that sink, it will just go outside, correct? Sink is basically that only. Same way, heat sink is basically, it will be a plate which made of a diamond, and whatever heat you're putting into that plate, it will be lost because of the thermal conductivity, high thermal conductivity. Okay. And there is switches voltage switches, there is transistors, there are diodes, there are many things. There are many things in this particular segment. Okay. The next is optics and photonics. See, again, this particular property you guys must be knowing better than me. Diamond is one of the best material in optics. So it is going to be used in lasers as optical windows, and it's going to also be used as lenses. Pretty sure in the future there will be an exclusive product where even the specs that we are wearing today can be made using diamond lenses. It's definitely going to happen in the future. Some rich people, they would like to have, diamond lenses. It's going to be a fashion statement in the future for sure, because diamond lenses can never be scratched. It can never be tarnished. The color of the particular lens will never ever get, anything else. So definitely there is a lot of scope in this particular segment. So again, so then there is medical applications. Again, like I discussed in the initial stages, diamond can be used in a lot of medical applications. Okay. Small diamonds can be made into biosensors. Let's assume pointers. I think you call it pointers, right? Less than a carat and less than even something like that. So those sizes, the pointer size, those kind of sizes, they're going to make biosensors in diamonds. So it is going to be like a pill. It is going to be like a tablet that we can swallow, or it's going to be like a tube that is going into our body, and it's going to check for certain things, right? So all of those biosensors can be made using diamonds because of its biocompatibility. And there is something called radiation therapy. Okay. There is radiation therapy in chemotherapy, right? I mean, you've heard about chemotherapy, all these cancer patients undergoing a lot of radiations, right? So these radiations, basically, they will have something called, like a device. I think the women over here, they use hair dryers, right? Similarly, it would look, the radiation chambers also would look something like a hair dryer. Okay. So diamond plate will be on the end of this particular radiation therapy machine. So what this radiation diamond is going to do is, all those radiation, it will focus into one point. So whenever people go for radiation therapies, this particular device can be used to accurately remove the disease in that particular point. And that is where, diamonds are going to be used. And there is another thing called implants and prosthetics. Prosthetics we've already discussed. So in any of the titanium plates or any of the other material, whatever it is, they are going to be coating it with diamonds, so that that particular plate becomes biocompatible, highly biocompatible, and it does not, get tarnished inside our body. So next is implants. Again, implants is same thing. We can have small diamonds created in the shape of bones. It can be included in any part of the body inside where it is operated. Okay. And then there is industrial applications. Okay. So industrial applications, it's already happening in today's life. It's not a future technology. In today's life, wherever you use cutting, wherever you use grinding, all of these places use diamonds. Even in your own polishing machine, where you polish the diamond, you know that the surface has a lot of small diamonds, correct? You must would be knowing this. So all of those things can be used in lab grown diamonds also, right? So in fact, it is more cheaper to use lab grown diamonds in all of these cutting wheels and grinding wheels. So it is going to be a major application of lab grown diamonds. Next is aerospace and automotive. Okay, like I spoke already, in your EV vehicles, all of these vehicles, diamond is going to be used as a part inside the engines, inside the gear, because diamond has a low friction coefficient. Okay, friction, you know what friction is, right? Friction basically is what makes us, again, move forward in life. Unless and until you are challenged, you are not going to grow, right? So same thing, friction. Friction is what makes everything move. So there are some places where you don't want a lot of friction, where there is a lot of movement. That is why you use lubricants. Oil is a lubricant that we have in all our bikes. All the guys over here, or even the girls who have bikes or cars, you must be knowing that you regularly put oil for lubrication inside the engine. Engine oil is this is what we talk about. Why we put engine oil is because inside the engine, the parts are made up of materials that have higher friction coefficient. So when the particular parts are moving, right, it is going to create a lot of wear and tear. If you don't have the engine oil, that particular engine will stop working, or it will become unusable within, say, 1 month or maybe even a week, depending on your usage. So this engine oil makes that engine run for even 6 months, 7 months. I don't know how long you take to change your engine oil. But if those parts are made of diamonds, inside, if there is a coating, then there is not much usage of this engine oil. I'm not sure if you're able to visualize it, but every part can be coated with diamond using lab grown diamonds. So maybe this is a big maybe. Maybe in the future, the concept of engine oil will not be present. Futuristic technologies will have a lot of diamonds because we don't want oil spillage. Oil is not good for our planet. Okay. All the oil that you spill on the ground and the sea, all of this is creating a lot of pollution. So the future people will not want oil in their systems. So what they're going to do is they're going to coat all those parts with diamonds. Or maybe if there is a better material that they invent in the future, they are going to use that only. Oil is not going to exist in the future. Okay. All right. So, okay, this is a huge bar, which I don't think we should go through right now. This is just a comparison between different technologies and what are the traditional material that is being used in today's life, right? And how diamond can be used in those particular places, and also what is it doing for that particular technology and how diamond is better. Okay, so this is something that I'm going to be letting you read on your own when you get this PDF. If you're very interested in what we have been discussing, this particular table will give you more information on all those things. Okay, I'm just going to talk about one thing, which is quantum computing, because like I said, it's going to affect your lives in a major way. Quantum computing in today's life, they use something called superconducting qubits. Okay, superconducting means you need a lot of freezing mechanism. That is, you need to bring the temperature below 0 degrees Celsius. It is temperatures that makes water into ice, right? So you need that kind of temperature for these kind of qubits to work. So in diamond, these NV centers in diamond, they don't need those freezing mechanism. You don't need a cooling mechanism at all. And if any of you have any kind of food companies, right, you must be knowing refrigeration is the highest costing method. So if you can talk to any of these ice cream shops, any of those people, if you can talk to them, they will tell you that the refrigerator that they have consumes the highest current. Okay, even in your home, even in your own facility right now, the classroom, the air conditioning that you have consumes the highest current, not the TV, not the microscope, not anything else. So refrigeration you need in a supercomputer today. But if you use a diamond in replacing the particular qubit as NV centers, you don't require the refrigeration. So a whole part of the supercomputer that is there today can be demolished completely. So the advantage of this is, if in the future we have supercomputing mobile phones, tablets, laptops, it is possible because of diamonds. Okay. So a lab grown diamond which has NV centers in it does not require any kind of cooling mechanism. So I'm just going to read this comparison, right? Supercomputing qubits require extremely low temperatures, like I just told you about, and complex infrastructure. NV centers can operate at room temperature. They are more scalable and they offer longer coherence times. Okay, coherence, I'll just explain about coherence times, making them promising for practical quantum computing. Okay, so coherence time, longer coherence time, diamond can offer. Okay, what is coherence time? Uh, right now, I think I can see three levels of tables, right? The first table, second table, third table. Um, in the first table, probably, I think you would be getting more information. This is just my assumption. So you might retain whatever I'm talking right now a little longer than people sitting at the back row, right? So the time that is taken to retain some knowledge is called coherence time. So in a quantum computer, basically what it does is it can retain that storage for a long period of time. And it becomes even longer when you use diamond. Okay. So this is just coherence time is basically meaning longer storage times. All right. Then that's it. I'm not going to talk about the other things because then I'm pretty sure you'll start sleeping. Already people are yawning and all that. Uh, so let's move forward. This, if you're interested, please take this PDF from Jerry and you can learn this when you're free. Okay. All right. So let's just throw some spotlight on some of the technologies that is going to come very fast. All of these pictures that you see on this left-hand side, these are all diamonds, basically. You might be a little confused why this looks black in color. This looks like a chip board that you see inside your phone and all that. Again, this is black, this is white in color. You must be a little confused. So all of these things are doped diamonds. We just spoke about it, right? So this particular black color is because it is doped with boron. Okay. So it is doped with a lot of boron gas. So basically the color changes to dark yellow, even brown color sometimes, like you see here. Okay, all of these are diamonds basically. So we're going to be talking about lighter electronics. So diamond basically has a low mass. Okay, so we're going to be using that particular quality and going to be making a lot of electronics using diamonds. So right now, today we have diamond heat spreaders, heat sinks or heat sinks. Then we have boron doped discs or electrodes. These are boron electrodes that you see on this top left. And these are boron discs that you see on the bottom. One is boron, lightly boron doped is in this color, white color. Heavily boron doped is in black color. Okay. So again, there are some products that can be achieved using this boron doping. Some of them are high power amplifiers, laser diodes, high performance computing. We spoke about electric vehicle, EV vehicle. Inside the EV vehicle, there are some electronic components. And again, aerospace means the rockets, the spaceships, all of these things that ISRO is doing, NASA is doing, all of those electronics can be using diamonds. They're already using diamonds today. In the future, a lot more diamonds will be used. Then we have something called optics and photonics, right? Again, we have a lot of diamond optical windows that is you can see on the left hand side. These are optical windows. So where this will be used is in lasers. So in your particular classes, you must be learning something about diamond cutting, right? How diamonds are cut. you use lasers, correct? So you know how the laser light is coming out through a particular portion, a transparent window, that is made of a diamond, basically. Okay. So all these windows that you see, that small gap you see in the center is made of diamonds. Why? Is because the light that comes in the laser, right? It has a very high temperature, very high temperature. If you throw your hand in between, of course, it is going to get cut. Why? Because the temperature is so high and no other material can sustain that particular heat. And we also discussed about how diamond can focus a light, correct? If a light is passing through the diamond, the refractive index, since the refractive index is so high, it will bend the light towards the center. So it will become more focused. So our diamond optical windows are going to be used in a lot of optics as well. And there are lenses, mirrors, like we already discussed, right? So all of these things are possible because of diamond's high thermal conductivity and its damage threshold, right? It will not get damaged if the temperature is high, pressure is high, all of those things. So this particular thing is going to use, so on the side, you can see this is a diamond mirror. And the bottom, you can see that is a diamond lens. All of these products are already prototyped. Already today, it's visible, it's available commercially in some of the companies. In the future, this is going to be widely available. Most of us are going to be using these products. Next is, again, quantum applications. I'm not going to talk a lot about it. I just want to show you these images, right? Because we have spoken a lot about these quantum. So quantum diamond, this is how it looks. It's slightly pinkish in color. The pink diamonds that you see, right, in today's world, even the natural diamonds, even the lab-grown diamonds, the pinkish shade, all of those diamonds can be used in quantum computers, in quantum applications, actually. So if there is a pink color diamond, it's basically a quantum type diamond. Okay. All of these diamonds, pink color diamonds, these are basically in square shapes because that is how it will be used in the quantum devices. But yes, so today there are research going on for quantum computing systems. In the future, there is going to be a lot of sensors, quantum sensors, because these are going to be working really, really fast. Okay, so that's why we need all these kind of sensors. Great. Okay, I'm going to be taking only a couple of minutes to discuss this. Not sure why the images are not visible. Okay, anyway, this is how a reactor would look. Initially, in the first slide, I had showed you some reactors, right? So we create all of our lab-grown diamonds today using CVD reactors. Most of them. There is another type of mechanism, I think you would be knowing also, HPHT. But HPHT machines are not commercially available right now. Not many people use it because we cannot grow a lot of diamonds using HPHT. Instead, a commercial method to grow these kind of diamonds is a CVD method. So again, all of these, there are different kinds of CVD methods, by the way. MPCVD is the most commonly used method to create all the diamonds. All the diamonds that you see that are created and sent to you for grading, that you learn about, mostly they are created using MPCVD. So in MPCVD machine, you can create jewelry grade diamonds, right? If you want to create these technological diamonds that we have just been discussing till now for the past 1 hour, you need different kinds of CVD methods like HF CVD method. Okay. There is LAP CVD method, and there is DC CVD, then there is PE CVD. So the expansion for this is plasma enhanced CVD, chemical vapor deposition. Then this is direct current chemical vapor deposition. Then LAP CVD basically means linear antenna plasma enhanced chemical vapor deposition. And then this is high frequency chemical vapor deposition. And this is microwave plasma chemical vapor deposition, right? So this is how we create our diamonds. Um, you can get in touch with some of these companies, in the future, if at all you're getting into this particular business. Okay, let's just quickly talk about the challenges that is in the way of making these lab-grown diamonds a future. Even today, the cost of lab-grown diamonds are relatively higher. Okay, the reason why we use silicon in all of our electronic components is because silicon is widely available, and silicon can be basically derived from sand, right? And we all know that sand is available everywhere. Mitti to, like the whole earth, wherever there is land, there is sand, right? So the cost of silicon is much, much lower today. So that is the reason why we still use silicon and not diamond. But for sure in the future, if we want faster systems, if we want more efficient systems, diamond is definitely going to be the material for it, and specifically lab grown diamond. So that is one of the major challenges that we are going to be facing. Then there is something called scalability. Again, silicon is used majorly because it is available everywhere, and we can get silicon from the sand, and we already have so many machines, more than 1 lakh machines in the world to create silicon from sand. Okay, so that is why it is very easily scalable. Even if they want to create 1 million more chips tomorrow, they will be able to source that silicon from these kind of companies. But today we have in India, we have around 10,000 CVD reactors. Okay, mainly in Surat, Mumbai, and in Jaipur. So it is going to be a challenge if diamond is going to be used in all of these things, because you cannot create so much diamond immediately. So scalability is going to be a challenge, definitely. Then there is public awareness. So today, some of you guys, because of this particular lecture, know that diamonds can be used in all of these things, correct? But the public does not really know. I'm sure most of you would go and talk about this to many people, because this is very interesting. All of them know only about jewelry. But diamonds actually, in the future, lab-grown diamonds are not going to compete with natural diamonds. Again, if someone is sitting here who is going to get into the natural diamond business, don't worry. Lab-grown diamonds are not the huge competitor for natural diamonds, because lab-grown diamonds are going to be majorly used for these technological purposes and not jewelry mainly, because there is a lot more commercial value for lab-grown diamonds when it enters the technology and not jewelry. That is the reason, if you had been following the diamond prices, the lab-grown diamond prices, you will be, some of you will be confused. The price of the lab-grown diamonds is continuously falling. If at all, if I get into lab-grown diamond business, what is going to be the future? You must be thinking that, right? That is happening mainly because if the price of the lab-grown diamond does not fall, it cannot be used in the technology purpose. And most importantly, some of these diamonds that we've discussed, especially quantum diamonds are more expensive than the jewelry grade diamonds that you see in your day-to-day life. Because to create a quantum diamond, you require a lot of scientific knowledge and a lot of efforts, a better machine. You cannot use a normal MPCVD machine that you use to create jewelry grade diamond. You need to modify that same machine, make it more efficient to create those kind of diamonds. So if any of you are thinking of getting into lab grown diamond jewelry business, don't you worry. The price will stop at some point, maybe in the next 6 months, it is going to stabilize. After that, there is not going to be any price drop because you cannot drop the prices further. Okay, because obviously you need some money to produce those diamonds, right? And you need some profits as well. So the future, the prices all a particular point. So don't you worry about it. And if any of you are going to explore this technological applications, trust me, it is a multi-billion-dollar industry. Any of these applications that you take, any of them, all of those applications are multi-billion-dollar industries in the future. Maybe in the next 5 years, maybe in the next 10 years, maybe in the next 15 years, but it is inevitable. It is going to happen. Okay. So this particular challenges will be definitely overcome with more better technologies in the future, but this is definitely going to happen. All right. I'm not just being optimistic here. This is where we are all heading towards. Okay. So the future outlook, like I said, it's very bright for lab-grown diamonds, not just in jewelry, but also in a lot of other applications. All we need is some research and development. Okay, some governments are already investing a lot of money, huge money. I think you would have read that in the last financial budget, Indian government itself had invested around 254 crores to IIT Madras to create a good technology. I'm not sure how many of you are aware of it, but Indian government does not spend money easily. They haven't spent the money on jewelry, but they've actually spent money on the technological applications, right? So any of you creating lab-grown diamonds, even for jewelry grade, towards the future, maybe in the 10 years down the lane, 15 years down the lane, you can always explore technological applications. Okay. So it's a very bright future for lab-grown diamonds. And that brings us to the end of this presentation, right? Not sure why it is not moving to the next slide. Maybe it does not want to finish. Okay. So we don't have a lot of time, guys. So I'm going to give you 10 to 15 minutes for a small Q&A. If any of you, whoever has listened, have any questions regarding what we've just spoken, you can let me know right now. I will try to address them. If it's not possible, we can get in touch after this presentation. I'm going to stop sharing, by the way. So you can definitely get in touch with me.
Hi, Harish. Can you hear me?
I
Harish, this is Rahul. I had written a couple of questions in the chat while you were discussing, but since I understand that you were
Oh, sorry.
chatting, so
Right.
so there was one important question which I mentioned, which I wanted to understand. So when you add boron, does it increases the fluorescence of the diamond?
Yes. So when I had told you about how boron is used in the growth process, right? We generally, most of the growers in Surat use boron gas to give a bluish tinge. And this actually increases a little bit fluorescence, even some phosphorescence, if that is another concept. So both of these things are getting modified when you include boron, because boron creates a lot of defects, right? So this affects its optical ability as well. That is how your I'm sure you
Correct.
just
But
said
what I
it, right?
mean is not the tinge; it's the fluorescence that you get when you put it under the UV.
I understand. So it's actually a very good question, Rahul. So fluorescence and phosphorescence are two different concepts that you notice when you have defects or when you have a structural, defect or whatever, right? So this particular thing happens when you add boron, not just boron, many other materials. So yes, to answer your question, there is definitely a change in the fluorescence when you add boron.
Yeah, thanks. So I have one more
Okay.
question. Yeah, I have one
Yes.
more question. So as you mentioned that there are a couple of applications, like there are many applications will be coming in future wherein uh, people might be using diamonds, LGD or some other aspects of diamonds. So are they using the polished version of the diamonds or the rough diamonds that they must be using it? Like I have no idea about that. If you can.
Again, a very, very good question. So to everybody that is listening right now, you have to understand that diamond diamond is special in jewelry only after it's cut and polished. But it's not the same case with technological applications. Okay.
Yeah.
So some of these diamonds can be in small forms. In like I just told you about pointer size, right? So these lab-grown diamonds are sometimes bombarded to make grits. So these are the grits that are used in some of these applications. Boron doped grits are used in water purification today. So you don't really need to polish those diamonds. There are a few applications, of course, like the optical applications. So to answer your question, Rahul, all of those optical applications, you need to have a polished surface because light, if it's entering into an unpolished surface, will get diffracted on the surface itself. So any other application apart from optical, especially electronics, especially quantum, you don't really worry about whether it is.
Understood.
So a small example also, Rahul, a very good question. So I just spoke about heat sink in between, correct? Heat sinks are those plates which will be able to spread the heat very easily. All these heat sinks are not polished. In fact, those are rough surfaces. We have two types of diamonds, okay? One is single crystal diamond. The other one is a polycrystalline diamonds. So single crystal diamond basically has a lesser roughness compared to polycrystalline diamond. Okay. So polycrystalline diamonds are generally used to create those heat sink discs. So you don't really need a polished surface when you talk about these technological applications apart from optical application. I hope I've given you enough answers, Rahul.
Yeah, thanks, Harish.
Yeah. Any other questions from any other people? Oh, I really wanted you to ask a question because you were one guy who was nodding about the session. Thank you so much for doing that. Yes, please. Please ask a question.
I'm Gautam Nanda, as you know.
Hi, nice to meet you.
Uh, one question I
What is your
wanted to ask.
question?
One question I wanted to ask is like any of these materials used to grow a lab-grown diamond are rare, like gases which are used or the materials that are being used, is those rare earth elements that might run out in the future?
Okay. Can you repeat that question because I'm a little confused.
I wanted to know, like, we are using certain materials to grow a lab-grown diamond, like earth elements, like
Correct.
gases, like methane and oxygen and other elements, or even a seed, diamond seed. Like any of those gases or the materials that's been used to grow a lab-grown diamond, a rare earth element. That is like it has a certain reserve and it might run out in the future.
Okay. Again, a very, very good question, Gautam. Thank you for asking this. In today's process, we are mainly using methane. So the production of diamonds in lab-grown diamonds mainly require you to have a carbon-sourced gas. Okay. So since diamonds are basically these carbons only, right? We are all talking about carbons, carbons, carbons. So what we are doing in the diamond growth process is we are depositing carbons on a diamond seed. So we are basically taking out carbon atom from a gas that has carbon in it. Okay. So even today, it is not just methane that is used to create diamonds. In fact, to be very honest with you, there are a few companies that are using carbon dioxide. So they call it carbon net diamonds, net zero diamonds. So a lot of governments today have this particular policy to reduce the carbon emissions, correct? So for that particular reason, there are a few companies that are using carbon dioxide. Carbon dioxide is a greenhouse gas, just like methane. So if the greenhouse gases go higher and higher, basically the temperature of the earth will increase. Okay. So we can use any of these carbon sourced gases. Especially we are using today methane is because methane is something that is abundantly available in purified form. Okay, that is the reason why we are using methane today. The other gases that we are using in the production of these lab-grown diamonds are hydrogen, okay, and then we use nitrogen, and also we sometimes use argon gas. Sometimes we use oxygen that we spoke about. Sometimes we use boron gas that we also spoke about. So to give you a fair idea, nitrogen in our atmosphere is around 73, 70. I think I'm not exactly sure about the number, but it's more than 70%. Okay. So nitrogen is never going to get depleted. First point. Second, oxygen, again, we still have around, I think around 20 percentage. It's somewhere close to that percentage. So again, we are not going to be depleted of oxygen again. And even if we get depleted of oxygen, in the future, we are going to be deriving oxygen from water directly. Okay. So you will never ever lose oxygen again. Then the other gas, the main gas that we have been talking about is methane and carbon dioxide. Methane and carbon dioxide are very little comparative to nitrogen and oxygen. But don't you worry, because methane today, in today's world, we are deriving from under earth. So there are a few people from the natural diamond companies. Even today, they say this as a marketing gimmick that, you know, lab-grown diamonds are not completely sustainable. The reason why they are saying this is there are two reasons. One is because we are using electric current from our garment. And this particular current we are using, our government is using these current, correct? We still don't have a lot of, wind power, water power, all those renewable energy. We still have non-renewable energies, right? So we still don't have all the capacity in electrical perspective. So second point is methane is still mined from under earth. So where is methane coming from is because whenever there is oil found, right? Oil mines, one of the layer, there is methane gas present. Okay. So that is how methane is derived today. All the cylinders that we get, methane cylinders, are mined today. There is another way to create this methane using biodegradable process, that is called biomethane. But even today, the purity of biomethane is not extremely high. You're right, Rahul, biomethane. I can see the chart right now. So this particular thing, even today, many people are still experimenting, because the purity of methane that I use in my lab is around 99.999%. So what that 99.999% means is, in that methane cylinder, 99.999% of the gas is only pure methane. So 0.001%, 001 is what there is other gases present. In fact, that methane can be purified even further. It can go up to 6 nines, 7 nines. We call the grade of the gases as 6, 9, 7, 9, 8, 9. What that means is, after 99 point, there will be 6 nines or 7 nines. Okay. So the purity of methane today, we are using methane primarily because purity of methane is very high. If you decide to use carbon dioxide or carbon monoxide, then you have to change your process a little bit. Scientists have created that. It's not that we have not done that till now. We have. All the greenhouse gases, that is carbon sourced gas, we can create diamonds. Only problem is the process will be completely different, and the technology that is going to be used to create them is going to be a little more complicated. Okay. So thank you so much for asking this question. To answer your actual question, don't worry, nothing is going to get depleted. So I forgot about hydrogen. Again, hydrogen and oxygen you can get from water. So towards the future, there is already that technology happening today. So water is used to create hydrogen and oxygen, even in today's world, in some of the applications, right? What that does is you can create pure oxygen, pure hydrogen. There will not be any trace of any other gases at all in that particular process, at least. Okay. So don't worry, your resources will still be intact. Any other question? Thank you so much for we time one question.
My name is Regis. I had one question about, you had mentioned that titanium can be coated with
Very sorry, I'm not hear you. Can you please come closer to the mic?
So you had mentioned that titanium can be coated with diamonds.
Yes.
So when we talk about something being coated, we generally have an idea that it's in the liquid form that things are getting coated. So are you saying that diamond is coated in liquid form, or is it like in gaseous form? It's like solidified or something?
Very good question. What's your name?
My name is Regis. Regis.
Jish.
Regis Lupus. Regis.
Regis. Oh, that's a very interesting name. That's actually the most interesting thing. All right, Regis, very good question again. I think you are confused because today in jewelry, you use liquid forms to coat things, right? But when we talk about diamond coatings, diamond cannot be present in liquid form. Diamond itself is so amazing because its structural integrity is so amazing that it cannot go from solid state to another state. Okay. And diamond cannot be gaseous state also. Diamond is diamond because it is in solid state. It is a different form of a carbon allotrope. Okay. So whenever we talk about coating, in diamond specifically, it is meaning that we will be depositing carbon atoms in a manner that it will go and form diamond over the material. So let's assume steel or titanium. Steel also can be used in this particular method, right? So when I spoke about engine parts and all, steel will be used there, stainless steel, something like that. So when we talk about titanium, titanium will be the platform inside the reactor. Okay. On the titanium platform, we will be depositing diamond over a small layer. So this layer will be a few micron thick. So microns is less than a centimeter, right? A few microns thick, or even sometimes some applications will require you to coat the diamond at nanometer levels also. So even 10 minutes, 5 minutes to 10 minutes, if you coat that particular material, a nanometer thick will be formed. That nanometer diamond will be formed over the material, right? So whenever we talk about coatings in diamonds, it is always in the solid. So the final form is in the solid form, but you use a gaseous phase to deposit those carbon atoms. I hope I've cleared your doubt.
Yes.
One last thing, Rajesh, I would also give you one clarification is diamonds, even though they are only in solid form, the size of the diamonds is where different kinds of applications are created. Okay. There are something called nanocrystalline diamonds. Nanocrystalline diamonds are diamonds that you cannot see with your eyes. It will be that small. It will be in nanometer level. Then there is even ultra nano micron nano diamond also, which will be even smaller. Then there is micron powder. So the powder that you see under the grinding wheels, right, where you do diamond polishing, in that the size of the diamond is in micron levels, a few microns. Then you find micron thickness, that is plates, discs, some coatings, all of those things. then you have more than a micron thickness. So depending on the size of this diamond only, different kinds of applications can be found. So there are even liquids which will have diamonds. Have you heard of it? I think they use that in some cleaning mechanisms. So in that, what it is not liquid diamond actually. Diamond is bombarded and made into nano diamonds, and those nano diamonds or micron powder diamonds are mixed in that liquid. Okay, so diamonds can never exist in any other form other than solids. All right, I hope I've clear. Thank you so much, Richish, for asking that question. Thank you so much, guys. I have to leave right now because I have other commitments as well. Thank you so much, Jerry, for inviting me for
Thank you.
the session.
Thank you very much, Mr. Harish. And I am inviting Miss Chaitra Chandar, our diamond faculty, to give the word of thanks. So she will take it. Okay.
Thank you, Mr. Harish. I think
Hi,
it was a
Chaitra. Nice
wonderful
meeting.
session. Yeah, thank you. Even same here. I think today our students have benefited a lot with this. So today they came to know that the lab-grown diamonds is not only for jewelry. There are other applications of this lab-grown diamonds also. So the pros and the cons and what is the future of this lab-grown diamonds also. I think they have a better idea today's session, and they have been benefited with the talks, and what we are not able to complete it in the classrooms with the sessions. I think those doubts were also being cleared in today's sessions. I think it was wonderful and it was more informative today's session. Thank you so much.
Thank you so much, Chaitra.
Have
I'll
a
see
good
you
day.
guys soon. Have a good day, you too. Thank you, Jerry. I'm
Sure.
leaving the meeting right now.
Sure, sure. Thank you very much.
See you guys.
Bye.